again, and welcome back to our next element, number 41 over here, Niobium, as we go down group 5. Now, incidentally, I forgot to mention the previous video, vanadium. I didn't mention that vanadium is now being looked at for the future of rechargeable batteries. This is being videoed on my phone, which has a lithium battery in it. Lithium is over here, and you can only recharge lithium a certain amount of times. And but the new batteries, vanadium redox batteries, they think you can charge up as many times as you like. So this is the future of batteries. And also on a sideline, something separately, this week the James Webb Telescope, which is has just been launched successfully, hasn't been set up properly now. It's unfolding as we speak. And it's going to be the largest, most expensive, detailed, amazing telescope ever launched into space. And it's to, one of the things it's going to look at is there alien life or life on other planets, exoplanets, and also how elements are made in stars, how they're made in suns, because the James Webb Telescope can see in infrared light. The Hubble Space Telescope at the moment cannot do that, and infrared light means you can cut through dust clouds and see things which have never been seen before, also the edge of the universe. The reason I mention that is check out our video on beryllium, because the James Webb Telescope has gold-plated beryllium mirrors, and the video talks about why we use beryllium to make those mirrors. Basically, it's strong and light. Anyways, here we go. Niobium, atomic structure, 41 protons in the center. And if you look at the element close up, you'll see that first of all, it's a metal, like all of these here, metals, till you get to about here. And it's not particularly hard, but it can be used to make a thing called a super alloy. A tiny bit of niobium added to steel, which is made of iron and carbon, a tiny bit, makes super strong. Now, niobium, its name, confusion time, because niobium has sort of two names. Now, it was discovered in 1801, over 200 years ago. This is when elements were just being discovered, and they didn't know how many elements there were. And they certainly didn't know the elements slotted together nicely on a table. And there was Charles Hatchett in 1801. Here he is, an English chemist. He discovered it from a lump of rock sent over from America. And the poetic name for America was Columbia, named after Christopher Columbus, an Italian explorer. And so Charles Hatchett called niobium columbium. And that name kind of sticks in America still. Now, about 50 years later, there was a German, in 1846, Heinrich Rose was a German chemist, and he discovered it separately, and he called it niobium because it came out of a lump of rock where our next video, tantalum, after this nasty guy, Tantalus, Niobe was the daughter of Tantalus, and because that element came out of that mineral, that's why he named it the daughter of Tantalus. So meanwhile, it had two names, and then 20 years later after that, it was finally decided, after a bit of argument with America and Germany and Europe, that it was going to be called niobium. And as a nice sort of like gesture in return, tungsten over here was being called wolfram, which is the W underneath. Anyway, they decided to call that tungsten. So the Americans got to choose this one. and everyone else got to choose niobium for its name there. Cool. So hopefully that clarifies how it got called niobium. It's confusing. Anyway, niobium, superpowers. Now, if you have a look, she has got a wire in her hand because niobium, like vanadium above it, has incredible tensile strength, which is when you pull something. It can make super alloys, which is an alloy is when you mix different metals together. And in the background, can you see there is this rocket? That is a nozzle of a rocket from the Apollo space program. Now, niobium gets mixed with titanium over here, and that made the nozzles quite a dark looking color because it's very stable, oxygen can't attack it very well, and it's got a very, very high melting temperature. And the last major use for niobium is in a thing called superconductors. What on earth is that? Right, here's a wire, here's some electricity going through it, and electricity is just the flow of these electrons through a cable, through metal. But when these electrons go through the cable, they bump into other atoms and cause heat. But a superconductor, and niobium can help make a superconductor, allows the electricity to flow through the metal really easily. It produces no heat, and as a consequence it can make really powerful magnets. And we use those magnets in medicine for magnetic imagery to spot things like cancer, and there is a lot of niobium wire used in something called the Large Hadron Collider, which is a particle accelerator. I know this. What is that? The largest, most expensive experiment ever done, and it's still operating today, is out in CERN near Switzerland. It is basically a huge ring, huge, 28 miles I think it is to go around, and they fire different particles in different directions down the tube and hit them together and smash them apart to discover how matter is made. Because beyond protons, neutrons and electrons, it goes even further. It gets weirder and weirder. But to accelerate the particles, they use magnets, and to make these powerful magnets, they use niobium. Where is she? Sorry, niobium wire. Which is this superconductor. Right, and so niobium, there it is, loads of superpowers, super alloys, super magnets, rockets, tensile strength, great for building, can't be attacked by oxygen, very, very cool metal. And next video will be about Niobe's dad, Tantalus, which is this nasty man under here. We discover why he's been made to stand waist deep in water for all of eternity. Not good. All right, take care. See you next time. Bye.